Black math! Give me some math and I'll give you some flack. Black math!
So we're going to go kind of quick, but don't let that keep you from asking questions. Now is the time to do that. You can always watch this video at home, but I think you are a good judge of whether, okay, I'm not going to understand this at home either. So ask those questions if you have those. Okay.
Mr. Flack,
Yeah.
you want me to show you my practice test? I didn't submit it on Schoology.
Yeah, I did ask for it at the beginning of class when you were in the bathroom.
I was.
Now everyone on YouTube knows that you were in the bathroom.
And then I left. And I left 5 spaces open.
Okay, thank you. I got yours, Gmo. You already uploaded yours, right? Good talk. All right, number 1. Simplify 7 over -3 plus radical 5. It's a no-no to have a radical in the denominator, but this is one that's a little bit more complex because you can't just multiply by radical 5, right? If it was just a radical 5 in the denominator, you can multiply by radical 5 because it would just give you 5. And whatever you do to the top, you can do the bottom. You can mess up the top as much as you want. You just can't have a radical in the denominator. But if you multiply by radical 5, it'll get rid of that. But it'll turn this into a -3 radical 5. So what's the solution? You remember the C word? Multiply by what?
Oh, no, I know this.
It's
Same
like,
thing.
it's in like, if you've ever taken Spanish or any foreign language or grammar.
Never taken that.
What happens when you do like when you blank a verb into all the, like I swim, you swim, conjugate. So this is the conjugate is the -3 minus radical 5. So the conjugate is just changing whatever that is. If it's addition, change it to subtraction. You're not changing anything else, just whether it's being added or subtracted. Whatever you do the bottom, do the top. The reason we do this is because when you multiply something by its conjugate, it cancels those middle terms when you FOIL it out. And those middle terms are the radical ones. So look what happens when I FOIL this out. I get +9, and then a +3 radical 5, and a -3 radical 5, and then a 5. Because radical 5 times itself is 5. And positive times a negative is negative. But look, boom, boom. So it cancels those radicals. So you don't have to do this because if you're multiplying by the conjugate, then you don't have to FOIL it. You just have to fool it, okay? You don't have to do the outside and inside because those are going to cancel. So you just have to multiply a -3 times -3 and radical 5 times negative radical 5.
With low, you just cancel out. Like,
yeah, so the outside and inside multiplication problems will always cancel out. So you're just left with F and L. So +9 and -5, right? Okay, so then you get 9 minus 5 is 4 on the bottom, but here you just distribute that normally. And this is ugly on top, but who cares? It can be as ugly as it needs to be on top as long as you have a nice, cute denominator. And that's it. That's it for number 1, yes.
Can you fix the key?
Yeah.
Thank you. Sorry.
Yeah. 1,000 things going through my head right now. I've been working on fixing that for a while.
Really?
So,
Yeah.
got issues. Okay, number 2. Simplify, blah, 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 blah. Oh, seriously? This is embarrassing. Did you guys get an answer for that?
Yeah.
You're just multiplying that. What'd you get?
5.1.
5.1, and it's cubic feet. All right. Any questions? I apologize for that question.
It's
I
okay.
looked at it and I got a little scared because I was like, "There's no way."
What am I doing
this is
wrong?
Easy.
So I had to do sig figs, but besides that,
Yeah, the decimal. Did it say sig figs?
it's implied.
Yeah, it's you don't have to do sig figs.
Well, I did sig figs.
Oh, so but is that right?
Yeah.
Okay, we're good. Number 3, simplify. Identify any excluded values. Okay, so simplify means factor first and then cancel what you need. But before you cancel, you have to identify excluded values. So I'm going to rewrite it: 5x minus 40, and then 56 minus 7x. Okay, so factor. What's the first step to factoring? Greatest common factor. What's the greatest common factor on top? 5. You take a 5 out, you're left with x minus 8. So far, so good? Okay. What's the greatest common factor on the bottom?
7.
So 7. You're left with 8 minus x. Okay. So this is, first of all, let's do excluded values. What's the only excluded value? Positive 8, right? So x can't be 8.
Oh, right.
So the other thing is, this is just the opposite of this. So pick any number for x. Let's say x is 10. 10 minus 8 is 2. 8 minus 10 is negative 2. So these are just opposites. So there is a way to reverse this so we can cancel it. Anyone know how to do that? So if this was a 10, if x is 10, then I'd have 8 minus 10 is negative 2. But if I reversed it, it would be positive 2. So then it was 7 times negative 2 is negative 14. So if I just negate this, then I'd still get negative 7 times positive 2, which is negative 14. So I can reverse this as long as I negate that. Okay? Because 2 negatives make a positive. So if you make this negative, that's fine. Just make something else a negative. So if I have 5, you can do this as long as you do this. You're fine. So that's what I'm doing. I'm negating 8 minus x by just reversing it. But the only way to make that justifiable is if I make that 7 negative. Okay? Yeah, just remember to, if it is reversible. Now, this isn't like x minus 8 and x plus 8. You're stuck with that. Those are two different things. But if it's x minus something and that same something minus x, then you can fix that. You can still cancel it. So now I can cancel it, and I'm left with a cute little negative 5/7 or 5 over negative 7. You can leave it 5 over negative 7. It's not pretty, but the negatives usually either go out in front or on top. Doesn't, either way, it's the same answer. Okay? All right, number 4. Let me write it out, and then we'll just tackle each term one at a time. See if we can simplify it or reduce the radical at least. Okay. Let's start with the easy stuff. This is actually a nice number. What's the cubed root of 27? That's 3, right? So this is just 15 times 3. Here is 4 times 3. Okay, but this is 7 times something a little bit more complicated. But we can reduce that. Actually, you don't have to yet. If you want to just combine the like terms first, and then we'll reduce it in the end, you got 7 radical 27s minus 3 radical 27s. How many radical 27s is that? 4 radical 27s, okay? So you can't find the square root of 27, but you can simplify it. What's the magic question? What are you looking for when you're simplifying a radical?
Something about perfect square. What's the
Yeah.
biggest perfect square? Then you go into it.
Yeah, so what's the biggest square that goes into 27?
I don't know.
What are the perfect
3?
squares? 1, 4,
Three's not a perfect square.
16, 9, 25, 36.
So 25.
So 25 doesn't divide into 27. What?
I don't know.
Oh, I thought you said it.
You said 9.
Yeah,
No.
so it might be worth doing this. Perfect squares, 1. Write these down. Then you just have to say, okay, which one of these numbers goes into 27? Okay? So this is the square root of 9 times the square root of 3. Square root of 27 is just the square root of 9 and times 3. You can simplify the 9, right? What's the square root of 9? So this is 4 times 3, and then you're just stuck with that radical 3. So that's 12 radical 3. So here's your final answer. You can simplify this. You got 45 plus 12, so that's 57 plus 12 radical 3. Now you could have combined these two terms first if you wanted to. 19 times 3, right? 19 cube root of 27s. Well, 19 times 3 is 57. So either way, you're going to get 57. You could have simplified these separately first if you wanted to, but then you're simplifying 2 radicals instead of just 1. So you would have been left with 21 radical 3 and 9 radical 3. Okay, so this should be comfortable for you, right? This one, you just have to remember how to reduce a radical, simplify a radical. So pull out the biggest square. So pull out that 9, it becomes a 3. Okay, so here's your final answer. Can't go any farther. All right, number 5. Graph the value of z. No, I don't know why I read graph. Find the value of z. Give the answer in simplest radical form. Okay, so this is just Pythagorean theorem. You could use the distance formula if you want, but that's just the Pythagorean theorem. How long is that side? How long is the height and how long is the length? Looks like 4, and the thing that you need to make sure it's not like saying, okay, every just one is 2 units instead of 1 unit. But it looks like every line is 1 unit, so you're safe. And then the bottom, what is that, 6? Okay. So the first thing I always look for, is this a 3, 4, 5 no, it's not. So I have to use the Pythagorean theorem, which is fine. What's the Pythagorean theorem?
It's a squared plus b squared equals c squared.
Okay, what's A, what's B, and what's C?
A is
4.
Doesn't
Is it
matter.
4?
4 and 4. So A and B are interchangeable. The only thing that matters is the C,
which is the bottom.
which is what you're looking for. So squared plus 6 squared equals z squared. 16 plus 36 equals z squared. So 52 equals z squared. So what's z?
I can bring down the actual calculator.
So what's z?
Would it be the square root of 52?
Yep.
Yeah.
Square root of 52. Now,
2 times square root of 13.
so 52, anything go into, so what did you're right. So how'd you get 2 times radical
My
13?
calculator did.
Calculated it. Does it give your answer in simplified radical form, your calculator? Well, that's nice. Well, you're looking for one of these numbers that goes into 52.
32. No. 4.
4 goes in there. Okay? So you can write it like this. 4 times 13. Okay? This is the way I do it in my head. So 4 times 13. So pull the 4 out. It becomes a what? 2. And then you're just left with that radical 13 in the radical. Okay?
So why did it go from a 2 to a 4?
A 4 to a 2?
Yeah,
you mean?
4 to 2.
Well, because you can, if you did square root of 52, you can factor tree that.
Okay.
So that's square root of 4 times the square root of 13, right? Square root of 4 is just 2.
Okay.
Okay? So some people, it makes more sense to do it this way. I tried forever to teach Grace Redderer this way, and she just didn't get it. And then I finally said, well, try it this way. And then she finally got it. So everyone's different. All right, next. Number 6, find the permutations. Okay, so all you're doing is just plugging in 8 for n and 3 for r. Okay, and then if you have a factorial button on your calculator, you can do that. But we're finding the permutations of 8 objects taken 3 at a time. So P of 8 comma 3 is just 8 factorial over 8 minus 3 factorial, which is just 8 factorial over 5 factorial. Now, you could use a calculator, or you could realize that, what's a factorial again? How do you do this if you didn't have a calculator? What's 8 factorial?
8 times 7 times 6 times
Yeah,
5.
all the way down. 8 times 7 times 6 times 5 times 4 times 3 times 1, right?
2.
Times
2.
2 times 1.
I was like,
Yeah.
we're skipping the 2.
So do you see how that's divided by 5 times 4 times 3 times 2 times 1, right? So really, you just need to know what 8 times 7 times 6 is. But if that's too confusing to you, just do that on your calculator. And you probably have to use parentheses, okay? Because, yeah, so 8 factorial divided by 5 factorial. What's your answer? Can you do that? Do you know how to do that on a calculator, your factorial button?
I'm gonna figure that out. Yeah.
It's the little exclamation point.
Yeah.
Yep.
Where is it? There we go. Well, for the 8, I got 4,320, but don't know the question.
Why
Correct.
did you write it in that order?
No, I did it wrong.
What?
Why did you write it in that order?
Because I was doing it like 56 times 6 in my head. 6, carry the 3, 5 times 6 is 30 plus 3.
Where'd you get 3?
Is that right?
Divide it?
Yeah, well, I divided it, but see you can divide it and you should get that. But what I did first, Avery, is I canceled out the 5 factorials because 5 factorial is inside of 8 factorial. So it just ends up with 8 times 7 times 6.
That's what I did wrong. Okay.
No, but what did you get when you got 8 factorial and 5 factorial?
That was like a really wrong answer.
Well, 8 factorial is a huge number.
It was 40.
It was 40,320.
Yeah.
And then what was 5 factorial?
120.
Thank you.
Yeah, so if you do that, you should get 336.
Oh, and they said, okay, then you know what?
So either way works. This is just if you want to cancel the 5 factorials. Okay, that was number 6.
Okay, then I did. Do you know where the button is? Did I show you? Yeah, usually you understand.
Okay, so we're just basically just creating equations out of these things. So I'm going to just do that first and not even copy down the matrices. So I'm going to say 13 equals x minus y. And then x plus z equals 16. 3 equals 3. I'm not even going to write that down. Y plus z equals 3. And then y equals -8. That's nice. That's a freebie right there. And z equals 11. Another freebie. Okay, so now I'm going to just plug in -8 for y and 11 for z. And hey, that works there. But now I can use -8 up here and then 11 right here. So that means x has to be 5. So let's just make sure it works here. 5 minus -8 is 13. That works. Okay. That's just a fun little puzzle. We didn't even have to do system of equations or elimination or substitution. Well, we did substitution, but they gave us what y is and they gave us what z is. Do you see how they just give it to us? Okay, because those matrices are equal to each other. So that means every component is equal to each other. All right, number 8. So far this test isn't too bad, huh?
You're gonna say that and then it's gonna be dot on my first one.
And then, well, you know that the practice test and the test are pretty much identical. 99% identical. They change the names to protect the innocent, whatever. Determine whether the graph is continuous, discontinuous, and or discrete.
Skip the 8 to 8.
Okay. Number 8, it's going too fast. Like, we're already on number 9. Now I've just wasted time talking about how we were already on number 9. All right, divide blah, blah, blah by 7x. Okay, now this little cheater thing that they give you, you can decide to use that if you want. You don't have to. So you can do it this way. Or you could just divide each term by 7x. Okay. Either way, you're going to get the same answer. Divide each term by 7x, you get 2x squared. And you don't really have to bring everything down because you're just going to get the same term over here. So I'm not even going to worry about that. Okay. So let's see, -1x, so -x. And then 7x goes into, and this is where it gets weird. Then they just leave it. On there, they just leave it 9x plus 4 over 7x. Well, I'm just going to simplify it. The x's cancel and you get 9/7. And then you just get 4 over 7x. Either way, I'll take whatever answer you want to give me. But the reason why they do that is because they're at the end of the variables, and now you just have technically a constant. So now you're going into the negative exponent variables. So I like this answer better. So just divide everything by 7x. Can you guys handle that?
Sure, maybe.
Okay. So you don't have to write it like that. So just put a line under every term and put a 7x under every term and then reduce it. Okay? Number 9, it's continuous. Do you see why it's continuous? Oh, it's not continuous. Do you know why? Because there's a little dot. So we had to take up, theoretically, we had to pick up our pencil and skip over 7, 5. So this is discontinuous. Okay, so 7, 5, we had to pick up our pencil and go over it. Okay, so that's why it's continuous. It's not discrete. Why isn't it discrete? What's discrete mean?
Discrete means there's no lines connecting points.
Right, so not discrete, because discrete means it's just dots. That's the best way to, I don't want to say just points, because this is technically just points. They're all connected, but just dots, okay? So it's not discrete. So if the function is discontinuous, name the x values where the discontinuity occurs. Where do you pick up the pencil on the x-axis? 7. So x does not equal 7. Or you could just say, they say, name the x values where it's discontinuous. So
you just write 7.
yeah, you can just write 7. Does that make sense, guys? All right. If it asks for the y values of discontinuity, what's the y value? 5. Right? If it asks for both, it'd be 7, 5.
I guess it.
Oh, never mind. I see.
Okay. The centripetal acceleration, A subscript something, C, of an object moving along a circular path is proportional to the square of the object's velocity. So v squared. So I'm going to say A subscript C is proportional to the velocity, the square of the velocity. So this is direct variation. Okay? And inversely proportional to the radius. Okay? What kind of variation is this? So it's not just direct variation, it's also inverse variation. So what do we call that? You remember the term? Either do I. It's like, it's both at the same time. So what was it? Like basically three or more variables. Write the equation. It's not complex. What is it? Let's figure it out. Finding out. Finding out. Finding out.
What do you do now?
So now I'm finding out the answer to this.
You're finding out.
Oh, yeah, finding out. Sorry,
The status report.
I'm slow.
Yeah.
So joint variation. It's called joint variation.
And sorry, where did you get the K from?
So that is proportional to
Doesn't
it.
that just like come with the?
So proportional means that like it's a multiple of it. So yeah, there's a scale factor. Yeah. So joint variation. So that's the only question you have to answer. Oh, and then you write the equation. Okay. So that K can go on top or it can go out in front. It doesn't matter. So basically, if it's direct, then that whatever it's direct to goes on top. Whatever it's inverse to goes on the bottom. Okay. Does that make sense? So you're really just translating this left to right. So A subscript C is first. That goes on the left. Object moving circular blah, 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 proportional to the square of the object's velocity. Proportional means K times something. The square of the velocity, V squared, it actually gives it to you. And inversely proportional, okay, so over whatever it says next, radius, R. Okay, that's it. So proportional, K times something, and then inverse over that something, whatever it mentions. And it's joint variation because there's two things happening. There's, and it doesn't have to be proportional and inverse. It doesn't have to be direct and inverse. It could be two things that are direct. That would still be joint variation. Okay, number 11. This is where it's gonna, the margin of error is gonna be gracious. Okay, so plotting the points, you got to do that right. But you guys know how to plot points. So I'm gonna just do a rough sketch here. And look, they make it weird. So see how the x units are more spread apart than the y units?
So, and we like, are you gonna be gracious on applying the points?
Nope. You got to get these points right.
Well, no. Well, I'm
So
talking
2.8 is about right there.
like I'm talking like, and it's not like exactly on the 2.8 because we don't really know like exactly where the 2.8 is.
Yeah, you do.
2.8.
I mean, if it's on the other side of the 10 on top, then I'm going to mark it wrong. But yeah, if it's in between the second and third line, then I'll give it to you.
Wait, what did you say this one down is like 8 something?
2.8, 4, 6, 8, 10, 10, 18, 14, 20. Okay, 16, 18, 20, 28, and 22, 20. Okay, so there's a pattern there, right? So you can just do your best guess and draw a line. So maybe there, okay? And now you have to write an equation. So you just need 2 things to write an equation. What 2 things do you need?
Rise over run.
That's slight, that's slope, slight, and you need a y-axis intercept, right?
mx plus b.
So y equals mx plus b. So remember, this is the slope, rise over run, and then b is your y-axis intercept. So let's start with that. Where does it cross? 4-ish or 3-ish. It looks like my line was 3-ish. Again, it doesn't, if it's anything ish over there, then you'll be fine. This is a positive correlation, right? So it's got to be positive. If you give me a negative slope, I'm going to mark it wrong. So you have to pick 2 points that are somewhat identifiable. When you draw it on the actual grid, you'll see where it crosses something nicely. I'm just going to pick this one. 0, 3, and then let's see here. It looks like maybe 7, 10. So 0, 3 to 7, 10. It goes up. It goes up 7, and then it goes right 7. So it kind of makes sense because this graph is wonky anyway. So that doesn't look like a 1 slope. But that's my estimated equation. Let me tell you what they said. They said y equals x plus 4. Drew was right. So it's still, they still got x. But if you get anywhere close to the slope of 1, I'm going to give it to you. Okay, so don't stress about this. The biggest thing you're looking for when writing an equation, I'm going to look at your line. And then I'm going to look at where it crossed and to see if it matches with your y-intercept of your equation. And then I'm going to make sure it's a positive. If it is positive, the one on the test could be a negative. Okay, is that all it says? Sketch a line of best fit, give the equation line. That's it. It might ask you if it's a positive or negative correlation. That just means positive or negative slope. It goes up and to the right, so it's a positive slope. All right, number 12. Given g of x equals 4x plus 9, 4x minus 9, and where d is real numbers, h of x is x plus 8. And D is integers. Find g minus h of negative 3. Okay, first thing you have to do. So g minus h of negative 3. First step. Negative 3 is negative 3 an element of both the domains. It's got to work in both machines. Does it work in the first and the second? Yeah, it is a real number and it is an integer. They use z for integers for some reason. So then you can move on. If it's not, then you're done. You say no solution because it doesn't work. Bathroom? Yep. Okay, so the easiest way to do it is just this, g of negative 3 minus h of negative 3. Plug it into the g equation, and then plug it into the h equation, and then subtract it. Okay, so let's see, so I'm going to get an answer there, and then I'm going to subtract. You don't have to write it all out. Just plug it into here, and then subtract. So negative 3 plus 8. So negative 12 minus 9 is negative 21 minus 5 equals negative 26. Is that what you guys got?
Yeah.
This is the easier way to do it. You could technically just write this with variables first. So you would have 4x minus 9 minus x plus 8. Well, that's confusing, especially because you're subtracting a parenthesis, and we all know how confusing that can be. Except you guys aced that test last week. Okay? And remember subtracting a parenthesis?
We did
And-
text last week?
No.
I was like, what? Where was I?
Okay, guys, functional notation is always confusing because it's not g times x or h times x. It's just the function g of x. So you have to kind of ignore the left side, that g of x. Just plug negative 3 into 4x minus 9, plug negative 3 into x plus 8, and then subtract the two things, and you're done. Can you guys handle that? Okay. So use Cipher matrix system to decrypt the message on the left. Okay, so this was actually an investigation. If you guys want to do this, you can. I'm going to skip it, but if you want to do it for extra credit, you have to go back and look at the investigation and do it yourself.
Are we allowed to just skip it on test?
Yeah, absolutely.
Thank God.
One question. What function would you use? Would you add those matrices?
Well, you'll have to look at investigation 4. So to decrypt the message. So it's just like a Cipher type fun thing that you can
It should
use.
tell us in the problem though, because you could do either thing. You could multiply them.
Yeah, there's a, right, but I don't know what it is.
On how you're supposed to use the matrix of it.
You should look it up. It'll be fun.
Well, I would not.
It's really because of COVID.
All right, subtract.
Right?
So 13 is extra credit. Hopefully people at home can realize that. I mean, you're welcome to try it if you want. 13, or no, 14.
13's extra credit.
Yeah. 14, subtract the rational expression. So we need to find a common denominator, which, remember, these have nothing in common, unfortunately.
So close.
So what's the common denominator with two things that have nothing in common?
Right.
It 1, 0. I don't know.
Well, that's the greatest common factor.
I don't know.
Least common multiple. When you add a fraction like 1/3 plus 1/5, what's the common denominator?
You just find, well, if it's like 1/3 and
15.
1/5, then I would just do 1 over 15
Yeah,
and then
yeah.
add the
So it'd be 15.
Yeah.
So when they have nothing in common, 3 and 5 have no factors in common. So you just multiply them together. So this one needs a 5 plus x. Whatever you do to the bottom, do to the top. Right? And this one needs a 5 minus x. Whatever you do to the bottom, do to the top. Right? This coming back to you?
Yes.
All right, so let's simplify that top there. What is that? 5 plus x minus, now here's that situation again.
Did you just FOIL that out?
Yeah, well, you distribute it. Foil, but foil is the bottom.
Right.
We can leave that. You can leave that. You don't have to foil it out. So this is minus parenthesis 20 minus 4x. Because you're subtracting this whole thing, not just part of the numerator, you're subtracting the whole numerator. So you need parentheses. And so this was that little test that I gave you last week. So let's combine, and this is all over that same denominator, 5 minus x times 5 plus x. So let's combine like terms. Can you do that in your head?
Those are 5.
What do you want to do to make this simpler?
Those are 5 plus x.
Chicken scratch?
Yeah. So what am I chicken scratching?
That one and then the negative 4x.
So
Oh, yeah, and that.
and
And
then,
then add that, yeah.
good. All right, now you can ignore the parentheses. So I've got negative 15 plus 5x all over 5 minus x. Okay. And there just seems like I could do something else. You guys see it?
No.
Let's factor this. What's the greatest common factor of negative 15 and 5x?
5.
So I can take a 5 out. Actually, I'm going to take a negative 5 out.
Yeah, so it'd be negative 3 plus x.
So it'd be 3 minus x and still nothing. So, because you can't cancel those 5s. But if this was like 25 plus 5x, then when I factored out a 5, I would have had a 5 plus x, and I could have canceled, or a 5 minus x, because that was negative, and I could have canceled. But luckily it's not, so this is it. This is your answer. This doesn't do you any good. So always check to see if for something you could possibly reduce or cancel a factor, but if you get this far, then you're good.
Okay, what if we gave you that answer and forgot to switch it back to that? Would you that? Yeah.
Oh, this is fine. This answer's fine. You can leave it like that, but it's technically not simplified because it's factored.
Right.
So, but this is fine. Just show all your work and you'll be fine. Okay? All right, number 15. Use Kramer's rule. You want to use Kramer's rule? I do.
Sure, it's easier.
Okay, so remember x equals, cover the x things and then reverse those things. So it's,
Just like do the one. I like the other one better.
you can do it if you want.
Because it's, well,
Over the coefficient matrix, which is 4, 8, 3, 6.
they're equal.
Okay, and then y equals, cover the y and do the matrix the way it's written. So 4, 8, negative 5, negative 10. All over that same coefficient matrix. Okay, so now it's just finding the determinant. How do you find the determinant again?
Like an upside down fish.
Yep, so negative 30 minus negative 30, what do you get? You get 0. Okay, 24 minus 24, you get 0. Uh-oh, what does that mean?
X equals 0. So, yeah.
X doesn't equal 0. What does X equal?
Or x 0 divided by 0. That is not a thing.
It's not a thing.
It's not a thing. It's
That's
not an
right.
answer.
Well, if it was like anything else divided by 0, it would be undefined. But it's 0 divided by 0, which means that this is indeterminate. So let's see, negative 40 minus negative 40, the same thing, we get 0 over 0. So that means our solution is not no solution. Do you know what our solution is? They're infinite solutions. So these are dependent equations. So if you were to use the elimination method,
That's what
or
I did.
anything
It was
like that?
So easy. It was so much easier than that. You just
and then they canceled out,
Yeah,
right?
'cause-
Everything canceled out, and you got 0 equals 0. So when you get 0 equals 0, or 5 equals 5, or 7 equals 7, then that is infinite solutions.
So I do have
Okay.
a question though.
Yes.
What if just the x and y cancel out? What if the
Right, good. Then you get like 0 equals like 7 or something. Is that what you're saying? Because if just the x and y's cancel out, but the constants don't, then it's no solution.
no?
Because 0 will never equal 7.
Okay.
0 will always equal 0. So if you get 0 equals 0, then it's infinite solutions. So it doesn't matter what you pick for x and y, it'll always be right. Okay, good. Great job. Moving on. So infinite solutions here.
So it's either no solution, infinite solutions, or what's the other one?
Or you just have a coordinate, like 3, 5.
Oh.
X equals 3, y, or whatever. Or one solution. Okay? All right, determine whether blah, blah, blah are solutions of the system of linear equations. You just plug them in. Okay? So, first of all, you can rule out that last one because, oh, wait. No, you're good there. All of them, all the x's are greater than or equal to -3, right? So that's not going to help us at all. So you can ignore that top equation. So now we're going to just plug these in and see if they work. So 5, 2, let's see. So 15 plus 10 is less than -5. Is that a solution? No, right? That will never be less than, that's not less than -5. So let's try 3, -3. So 9 plus -15. Is that less than -5? -6 is less than -5. Yes. Okay, let's try 2, 7. I don't think so, because you're going to have a positive number. Okay, so your only solution is 3, -3. Just plug them in, see if it works. Can you guys handle that?
Sure.
Okay, number 17. Solve the system equation by substitution. All right. Well, that's nice because y equals, they already tell you what y equals. So all you have to do is plug in x minus 5 for y. So 3y equals 3x minus 15. So far, so good. All I did was plug in that for y. So now I'm just going to simplify and solve. 3x minus 15 equals 3x minus 15. Oh, one of these guys. So what's our solution set?
Would it be infinite?
Infinite solutions, because you're going to get 0 equals 0 when you try to solve that equation. Okay? Nice. All right. 18. So if you would have had 3x minus 15 and then 3x minus 17, then you would have gotten 0 equals like 2. Well, 0 will never, or negative 2. So 0 will never equal negative 2. So no solutions. All right, number 18. Determine the vertex and axis of symmetry of this guy. Okay, so this kind of, if you guys remember these rules, if you want to write this down, it's so nice because it's already written in the form that tells us how much to shift it left or right and how much to shift it up or down. The 3 just is how skinny or fat it is. But you don't have to worry about that because you're just looking for the vertex and axis of symmetry. The axis of symmetry is the x value where the mirror is, where it reflects, okay? So to do this, remember, this is your mother function, and then it shifts. How far right or left does it shift?
5. Or is that up and down?
That's up and down.
-2 then.
So this shifts the opposite of what you're seeing. Shifts -2. And then, but the vertical shift, see how this happens inside the parenthesis with x. This is what is added or subtracted to x before the function happens to the x. The x, what the x is doing is something squaring. But if you add or subtract something to x before you square it, that's a horizontal shift. And it's the opposite of what it looks like. So if this is x plus 2, you shift it left 2. If it's x minus 2, you shift it right 2. Remember that. And then this guy is nice because it's just exactly what it says. Vertical shift, up 5. So left 2, up 5. So this is where it ends up, right here. And actually it's, is that a negative? -3, so it actually goes down. But it doesn't matter because you're just looking for, so that flips it. So does it say sketch the graph?
No, you don't have to graph.
Yeah, so that's what's funny. If you were to sketch it, just make it a little skinnier. But if it's a fraction, then you make it fatter, okay? And if it's negative, you point it down. If it's positive, you point it up. So the vertex is at, the vertex, we went left 2, up 5. So that's where the vertex is, -2, 5. So the axis of symmetry is the x value, -2. X equals -2. So see how that's the axis of symmetry? Because it's the same on both sides. So this is a pretty easy problem if you remember where to look for the horizontal shift and the vertical shift. So it happens inside the parentheses, so go left 2 and then up 5. Okay, so your vertex is going to be -2, 5, which is left 2, up 5. And your axis of symmetry is x equals whatever your x value is of the vertex, -2. All right, number 19. Divide and then evaluate for x equals blah, blah, blah. So copy dot flop, 24, x to the 4th over 7xy. Flop that second one, 7xy cubed over 12x cubed. Take out your red pen. The 7's cancel. The x's cancel. Y and y cubed cancels. It just takes away a couple of those. So it's y squared, or it takes away one of those. 12 and 24 reduced to 1 and 2. X cubed and x to the 4th. All the x's cancel except 1 on top. So you're left with, let's see, 2x y squared over 1. So you just do that. Because everything on the bottom cancel. See that? Cross canceling? You don't have to cross cancel. You can multiply it across if you want. 98 x to the 5th y cubed over 84. No. Oh, what's 7 times 12? Not 98. 24 times, yeah. It's going to be like 168. Yeah, and then you can reduce your answer if you want, but nobody likes to do that. That's annoying. Okay, so number 20, put this in slope-intercept form and then graph it. So how do you put something in slope-intercept form? Get the y by itself. Okay, so we have to get rid of that 4x, right? How do you get rid of 4x? Subtract 4x, or just put it over on the other side. So you're left with negative 2y equals negative 4x plus 4. You can say 4 minus 4x, but slope-intercept form, we like the x term first, so you're eventually going to have to move it around anyway. Okay, and then you have to divide not by 2, but by negative 2 to get positive y by itself. So then you get y equals, divide both of these by negative 2. Negative 4 divided by negative 2 is just positive 2x. 4 divided by negative 2 is negative 2. So here is your equation. How do you graph that?
Start at 0, negative 2. Yeah.
Yep, start at your intercept. Good. And then what?
2 over 1.
So up 2 over 1. Remember, this is your slope is what x is being multiplied by, and it's rise over run. So if it's not a fraction, think of it as a fraction or write it as a fraction. So up 2 over 1. So rise 2, run 1. Up 2 over 1, up 2 over 1. Make a couple points, connect the dots, and you're done with the test. Okay? If you have any questions, you can ask now, or if after you watch the video you're still confused, message me and we'll figure it out. Okay?